So I want to welcome everybody who's here and everybody watching online. My name is Shawn Huddy. I'm the manager for strategic partnerships with CERIAS. Thanks again for tuning in. And our speaker today is Dr. Wen Masters. She's a science and technology leader and strategist with a 30-plus career in government, academia, research and development, and non-for-profit organizations. She leads impactful science and technology research and development. Currently, Dr. Masters is the VP for Cyber Technologies at the MITRE Corporation, a not-for-profit organization that manages six federally funded research and development centers with a mission to solve problems for a safer world. Dr. Masters drives MITRE's strategic strategy. She champions for MITRE's cyber capabilities and oversees MITRE's innovation centers with a team of 1,200 professionals, addressing the nation's toughest cyber challenges to deliver solutions for sponsors and the public. Before joining MITRE, Dr. Masters was the Deputy Director of Research at Georgia Tech Research Institute, involved in data science, communications, computational science, quantum information science, and more. And Dr. Masters will give her talk today on cyber risk analysis for critical infrastructure. And I will hand it over to you.
Thank you so much.
Turn that off, or
I can use this. Thank you so much, Shawn. First of all, I would like to thank CERIAS for this opportunity, and I'm really thrilled to be here to talk with you about a recent development at MITRE focused on cyber risk analysis for critical infrastructure. So Shawn had already mentioned that MITRE is a not-for-profit organization that manages 6 federally funded research and development centers. So I will also add that a part of MITRE is MITRE Labs, and MITRE Labs functions as the research and development engine for MITRE. And we also manage an independent research program there. And here's some quick stats. MITRE has more than 60 years of history, solving tough problems for a safer world. Started with solving national security challenges. And now we branched out to support health, to support enterprise modernization, and to support homeland security and aviation and transportation and more. So more than 9,000 employees, 65 plus locations worldwide, and many patents. We are, our forte is really applying systems thinking to solve complex problems for the well-beings of the citizens and then for the safety, stability of our nation. I had alluded to that I was going to talk about the work that's recently developed at MITRE Labs, focused on doing cyber risk analysis for critical infrastructure. So I like to give acknowledgement to the team at MITRE that did this work. First of all is the, we call it Infrastructure Susceptibility Analysis Team. And that team is led by Sarah Freeman and Mark Bristow. And we also have the MITRE Attack for ICS team, whose work is an integral part of this. That team is led by Jake Steele. And also MITRE Caldera for OT team. And that team is led by Michelle Belial and Blaine Jeffries. So for completeness, I like to actually quickly mention what is considered to be critical infrastructure, or rather, what are the critical infrastructure sectors? Defined by CISA, there are 16 of those sectors, including power and energy, manufacturing, communications, chemical, information technologies, health, financial, of course, food and agriculture, emergency services, water and wastewater, and transportation systems, as well as the nuclear reactors, including materials and waste. And of course, there are also the government facilities, as well as commercial facilities. So as you can see, those are critical infrastructures, right? Underpins our daily life and also underpins our national safety, security, and economic development. So why are we working on cyber risk analysis for critical infrastructure? In fact, about 2 years ago, MITRE stood up a dedicated innovation center focused on protection of critical infrastructures from cyber threats. So here I plotted out a timeline of selected attacks, cyber attacks on critical infrastructures. If you are familiar with them, you can see they are all targeting at different sectors and with different objectives, using different technologies, and the frequency of that is increasing, including nation-state actors attacking critical infrastructures. In fact, if you look at 2015, the Ukraine Black Energy attack, that was attacked by Russia, state-sponsored the actors. And it was actually used as a warfare activity, right? One nation against another. It was first publicly known successful cyber attack against a country's power grid. And between 2011 and 2013, the gas pipeline intrusion campaign was conducted by Chinese state actors, targeted 23 US gas operators, and with 13 confirmed compromises and 3 near misses, and 7 in various different stages of intrusion depth. And so the 2017, the Triton attack is really attacking the industrial safety systems. So many of these other attacks are focused on SCADA systems, right? PLC, for example, such as the 2010 Stuxnet attack and some of the other subsequent attacks. And so we can really see the sophistication of those threats. And of course, we can also infer their objectives. So at MITRE, we believe cyber physical systems security is an interdisciplinary team sport. It really should be 3 important aspects or important teams from different perspectives working together, incorporating or integrating threat intelligence, engineering knowledge, and cybersecurity expertise together. In the recent decade, in fact, the cybersecurity and engineering domains have matured substantially and really working hand in hand to look at various means and technologies to realize cyber resiliency for those critical infrastructure. Threat intelligence, on the other hand, remains a significant challenge. But in order to understand the threat posted or the risk posted by cyber threats, threat intelligence is a very important component, both from post-mortem type of analysis, for example, a lot of already observed TTPs, and as well as some anticipated potential intentions and objectives in order for us, the defenders, to prepare, do the preparatory analysis, to prepare our infrastructure so that we can continue to function during attack. Okay, so as I said, the threat intelligence piece remains to be a challenging problem. So what we set out to do is to work to improve that particular piece. So first of all, what is a cyber risk, right? How do we understand cyber risk? What are the relevant factors? I think most of us are familiar with the basic risk concept, and meaning the risk is really probability times impact. That's how organizations have always been using to determine risks. But when we talk about risks posed by cyber threats, there has to be a threat actor who is attacking your infrastructure or your network for the probability to be non-zero. Because if there is no threat actor, the probability of attack is zero. And once we realize that, so we say, okay, so apply that basic risk concept into cyber domain, then we will look at risk as really a combination of a threat and impact. So now, since our focus is to improve the threat intelligence, cyber threat intelligence, in this particular case for protecting critical infrastructure. So we look at how we can logically decompose the cyber threat factors. So we look at it as attackers' capabilities and the opportunities presented to those actors. And of course, motivation, right? Some of the motivations might be just, getting money, like a ransomware attack on Colonial Pipeline, for example, right? And some other similar attacks to some hospitals. But the Russian attack on Ukrainians' critical infrastructure, that motivation was very different, right? So the impact also would be very different. And then we thought more about opportunities. In particular, if we are looking at skillful threat actors, both nation state as well as your regular hackers, right? The persistent, determined adversary will eventually achieve success, right? So our focus then turned into capability, motivation, and impact. So that is the concept that we followed to develop the infrastructure susceptibility analysis. And as I mentioned earlier, CTI, or cyber threat intelligence, for critical infrastructure, particularly applied to risk analysis, in order to enable accurate decision making to address those risks, needs to include other sources of intelligence as well, not just observed cyber threat, TTPs. And so we incorporate all sorts of threat intelligence. So now come to the infrastructure susceptibility analysis. So we have 4 major areas in this analysis framework. Identifying attacker capability, defining attacker objectives, describing technology functions, and understand effects. So those are all very important earlier when I mentioned about, the team sport. So you think about incorporating engineering knowledge and the OT environment, specific OT environment, right? That's where your technology functions are, and that's where you have to understand the effect, because the effect is a physical effect. Okay. So those are the major areas in our ISA, in the infrastructure susceptibility analysis framework. It is a semi-quantitative analysis because some of those analyses don't necessarily have very high confidence. So we have to apply some subjective kind of, characterization on them. And this, the outcome, of course, our goal is to identify the most likely attacks in addition to the most damaging attacks. And this is meant to be a systematic and repeatable process. And so it can be scalable to all different sectors. And so this is the 4 core analysis area that I mentioned earlier, and this just adds a little bit more details. But in an essence, this really allows us to know ourselves better and know our adversaries better. So we can ask questions such as, what is critical to our process? What can we do without? Would we see an adversary in our system? Can we be resilient under attack, active attack, right? And we can also ask questions about our adversaries, such as who would target us? What would their goals be? With what capabilities? And what would they need to do? So this is just a little bit more details on the 4 core areas of ISA. Now, I'm going to say a few words about capability sophistication. I think for the cyber threat intelligence analysts, if any one of you have done that, we often hear reports that will say, this attack is more sophisticated. They use sophisticated toolkits and sophisticated attack. But rarely was there a concept to really qualify what do we mean about sophistication. So we decompose that sophistication into 3 domains. One is effect, the other one is access, and another one is targeting. So by effect, we mean weapons used by an adversary to conduct a cyber attack and the end effect of a campaign or incident. By access, we mean adversary tools, techniques, and methods to gain access to the technical target of a cyber attack. And by targeting, we're talking about tools and techniques leveraged by an adversary to gather the necessary information to support CNO. For those that are familiar with MITRE attack, we also have MITRE attack specifically for ICS. And some of those artifacts that I mentioned can be mapped to MITRE attack, which gives you a means of characterize how the threats are behaving and how we can design our defensive measures. Okay, so the infrastructure susceptibility analysis process consists of 4 steps. The first one is to identify existing capabilities. And the second one is define attacker objectives. And the third is to describe technology functions. And the fourth step is understand effect. So to identify existing capabilities, we review past incidents and attacks for tools and other TTPs. And key questions we ask here are, what technical effects capabilities have been demonstrated against the real-world victims as part of a past attack or domain? What vulnerabilities are leveraged by the attackers? What was the result of these access campaigns or attacks? And as I mentioned earlier, when I was talking about sophistication, that many of the artifacts can be mapped to MITRE attack for ICS. And in fact, they can also be mapped to a similar CTI model, such as the SANS ICS kill chain. So you can use all of those models. Now, in the second step, to define attacker objectives. So this is where all source intelligence comes to play. We review all available intelligence or other indicators, right, that may identify or illuminate programmatic goals. And we ask questions such as, are actors pursuing capabilities against a given sector or technology? In what sector is the equipment commonly deployed, or in what country, regions, or companies, right, is the equipment commonly deployed? Because if we know all of that and we can see a particular technology they use to attack us, then we have an understanding of which sectors might all be or could be affected. And the third step is to describe technology functions. This is about understanding our engineering, design, and our critical infrastructure systems functionality and our mission, and what's critical to us, what we must protect, and what we can actually do without, type of thing, right? And so questions such as what is the engineered purpose for a given cyber-physical system? Right? How is it designed, deployed, commissioned, and maintained throughout its life cycle? Now, that question is actually very important, and particularly if we factor into all the supply chain issues. And who are the key players or organizations throughout a CPS life cycle, right? And what are the necessary technical targets for an attack, given a desired outcome. Finally, the fourth step is to understand effect. And this is really for us to define outcome given a system failure or loss of availability. Okay, so key questions here we ask are, what technology failures have occurred in the past? What was the result of those technology failures? What was the cost and process of recovery from those technology failures? It's also a very important lesson learned, right? That can inform us in terms of how to design our systems better, improve various designs, make it more resilient. And what system or business interdependencies exist. Those could be vulnerabilities, right? To be either mitigated or, they will be attacked, right? Okay, so a few words about, in order to do our infrastructure susceptibility analysis, as I mentioned about going over the process and all that, we have to leverage intelligence with good understanding of confidence level for this to be somewhat a quasi-quantitative, to come to a quasi-quantitative risk kind of understanding, and then make decisions accordingly, right? And so known TTPs and leverage the CVEs, those are high confidence intelligence. But ease of exploitation or observed methods of other actors, those are typically much lower confidence levels. And in between, the high confidence and low confidence are things like programmatic goals, motivations, procured materials and training and research, etc. But all of these together, and with the right characterization of confidence level, gives us the understanding of likely attack path. I would like to also mention MITRE Caldera for OT. My previous slides mentioned about all of those potential information that is needed to arrive at a most likely attack path. MITRE Caldera is an open source resources on GitHub, and it is an emulation tool that emulates adversary actions in OT environment. In September this year, we released Caldera for OT jointly with CISA. And that allows the defenders and designers to emulate how what might be the potential attack means and path in our system. So gave it a try. It's open source. Okay, that brings me to our conclusion. So to summarize, infrastructure susceptibility analysis is a focused analytic approach designed to identify the where and how attackers are likely to target our OT environments. And our future research and development focus on this it concerns calculating defender gains via specific system, procedural, and architecture modifications. And of course, our overall goal is to improve organizations' ability to employ intelligence and threat information coupled with engineering knowledge of their OT environment for efficient risk reduction and effective security gains. With that, I'll open up for questions.
Attendees, you can put your questions in the Q&A area of the Zoom. Okay, we have one question here from Solomon. So what are the most common attacks seen by MITRE?
Common attacks seen at MITRE. Well, I would say all kinds, all spectrum.
Okay, and we have another question from Rahul. With increased automation of homes and workplaces, is ISA really equipped to predict all future possible risk and attacks?
Of course, no tool can do that, right? And we developed ISA with a specific goal in mind, that is to really help the critical infrastructure sectors. And in particular, think about most of the critical infrastructure are operated and owned by private sectors. And there is always the resource prioritization decisions by those organizations to decide where they will put their mitigation measures and what to spend money on, right? And so if we can help those organizations appreciate how susceptible their systems are for cyber threats, and then we can enable them to make better resource decisions.
Great, we have another one. This one's from Courtney. Has your research fed back into MITRE attack frameworks to address gaps in their coverage?
Yes. Yeah, we work together as a team, feed our knowledge and insight and lessons learned with all the teams.
Another question, this one's from Nicholas. What are some of the quasi-quantitative metrics being used to assess likelihood of specific OT attacks?
So it's typically a scoring mechanism when we understand of course, you first have to decompose each system itself. And as I mentioned, there were several particular aspects of things, right? And then we score them against various artifacts and effects. And then it's a probabilistic measure, weighted, and we come to that relative scores. Yeah, go ahead.
You mentioned looking at.
So I'm sorry, there are microphones on there's a button, press that microphone button. Yes. Right, but they're light up. No, there you go.
Okay. So you mentioned looking at past attacks to help identify like existing capabilities. Where you mentioned CVEs for data, but is there any other data sources that you guys use to look at past attacks?
Yeah, there's a lot of reports out there.
Mm-hmm.
Yep.
Okay, so just general reports, not any specific. Okay.
Yep.
We've got another one from online. This is a good one. So again, from Rahul, it might be a silly question, but is it really wise to have open source tools like Caldera out in the open because it might give attackers an idea for designing their attacks?
That's a great question. I'm gonna answer that by telling you a story. So when we developed the MITRE ATT&CK, that was 10 years ago. In fact, we just celebrated 10th anniversary of MITRE ATT&CK. And initially, it was just a government-sponsor funded work, and results was delivered to government sponsor. And then we had this debate in MITRE. Well, should we make this capability this as a resource to the public? What are the pros and cons? And of course, if we make it a public domain resource, the attackers will see it as well, right? But in the end, we believe it's much better. It will benefit all the defenders. What's better than help raising the sophistication of all the defenders, right? And because we have to be fighting against cyber attackers together. And so I think 10 years later, we see that was the right thing to do. Right? So same thing with Caldera, because we want to help everybody. Yeah, there will be bad guys, take advantage of various technologies, but that's not new. That happens all the time.
Okay, great. I don't see any more questions, but thanks again, Dr. Masters. Really appreciate you coming to Purdue and visiting with us. You're always welcome to come visit.
Thank you. I had a blast talking with various professors and students here, learning about their work. So it's absolutely wonderful. Thank you so much for having me.